In the last video, we saw examples of how to use, how to basically do a binomial expansion using combinations. In this video, I'm going to explain some of the uses of binomial expansion. So why would we ever need to expand to, say, to the power of 10 or power of 4, and like, why is that ever useful? So one of the uses of binomial expansion is in probability theory. We have something known as the binomial distribution. Binomial distribution. And we'll go over it a little bit later when we do probability theory, but basically what it is this is the probability, I'm just going to write prob, of an event happening over a number of trials. A number of trials, right? So the way we sort of describe this is kind of like sort of the informal way of describing it, but here, P is the probability of the event happening, Q is the probability of the event not happening, and N is the number of times you're going to try it. So in other words, the number of trials that sort of this event will take place. So let's sort of give an example of this. So for example, let me just scroll up here. Okay, so one example is, say for example, we want to find the probability of getting 20, so say we're flipping a coin. So we're getting 20 heads after flipping a coin 100 times. Okay? So in other words, if you flip a coin 100 times, what's the probability of getting sort of 20 heads? Not necessarily 20 heads in a row, but over the 100 times you get 20 heads in total. So the solution to this, actually, the probability of this is actually 100 choose 20, right? P to the power of 20 and Q to the power of 80. So in other words, what's happening is over 20 times, so over 100 times, we want 20 of them to be successful, and really what we want is 80 of them to be not successful, because we are just looking for exactly 20 heads. And this 100 choose 20 over here, this sort of tells us the number of times, the number of sort of different variations of how we can get 20 heads over and 80 tails, basically. So for example, we could get 20 heads in a row and then 80 tails, or we could get a tail, head, tail, head, tail, head, until we get like basically 20 heads, and then the rest of them would be tails. And so this over here sort of does the counting for us. So if you observe, this really looks very, very similar to one of the terms in a binomial expansion. And that's really what basically the binomial distribution is. It's just basically a form of the binomial expansion. So that's one very, very important example. The binomial distribution is really important if you want to determine the probability of something happening or not. And we use the binomial theorem in order to help us determine what our probabilities will be. All right, so in the next video, I'm just basically going to go over a couple of problems that you'll sort of see in your problem set, and sort of some ways to solve them. All right, so see you in the next video.